All right, let's get going. Good morning, everybody. Welcome to some fun. My name is Quentin Van Diemen. These days, I'm a principal in the Office of the CISO within AWS Security, and I'm here with Kevin today.
Hi, my name is Kevin Lee. I'm a Senior Product Manager at KMS Service.
Awesome. So today we're going to talk to you about a topic that I know that I'm particularly passionate about, this notion of using encryption and authorization together and in unison to create even greater data protection outcomes, right? Now, in some ways, this is not a new topic. Some of the things you'll see here today have been true for many, many years in AWS, but they're really powerful, and we're going to bring them back to light and show you how to use them. At the same time, this topic has really gone through some dramatic enhancements in the last couple of years. Like the level which we're able to take these concepts has meaningfully changed, and we want to make sure we highlight those for you as well. So now, I'm not going to give you some sort of cheesy metaphor about data being the lifeblood of your organization or anything like that, but sort of whether you're a big organization, small organization, everybody's got data, right? And what we're going to really deeply look into today is how we use encryption and authorization in unison to protect that data, right? How we write rules so that your data can only be accessed under the very, very exacting conditions that you expect and that you define. Now, I'm using that term in unison very specifically, right? It's more than together. These things aren't just defense in depth. They aren't just serial against each other. They're actually aware and augment one another, right? And we'll see this deeply. But this intersection, this way they come together, allows us to really write robust, flexible, and granular rules about data protection that is far greater than the sum of the parts. In unison, right? Okay. So now to do this, to walk us through how we use these things together, we're going to line everything up against a couple of categories of real-world examples, right? These are scenarios that come from Kevin and I and many other Amazonians talk with great customers like yourselves. First, we're going to look at how these two come together in order to help us create even more exacting least privilege that works across numerous dimensions, taking who can access what, under what conditions, and really showing you the types of exacting controls that you can arguably only write in AWS. Next, I'm going to hand it over to Kevin, and Kevin's going to walk you through how you can go fast and stay secure, right? How you can take the traditional OR that is involved when it comes to data protection and make that an and. And then finally, we talk a lot about keeping humans away from the data, right? And Kevin's going to show you how we can really effectively protect data from all the humans, but even those that hold the keys and that write the policies, right? Trusted as they may be, we still need to protect them from them. Now, if you've been in AWS for a while, right, encryption and authorization sort of always work together. But it's interesting or at least worth reminding ourselves that on-prem, these are actually fairly siloed technologies. They're implemented. They're generally both implemented, but they're implemented by different teams. They're implemented with different goals in mind. And in some cases, they actually work counter to one another, right? It's very often that encryption on-premise creates bespoke identity management and secrets management challenges, right? So that's the contrast that we're avoiding here. So now over the next hour, we're gonna start fairly simple. We're gonna use the backdrop of a simple application, right? A little marketing application that we sort of fictitiously made up. And we're going to see this application evolve. And we're going to see it evolve through very discrete, tangible steps, right? We're going to first describe each one of those steps in very just simple human terms. What are we trying to do? And then we're going to walk through the technical bits and bytes about how to get it done. Now, by the end, we're going to have security really dialed up to 11, right? It's going to be we'll see what y'all think afterwards, but it really impresses me what we're able to do here. Now, at the same time, it's important to keep balance in mind, right? We're going to help you see what along this journey, we're going to help you find the balance that's right for you, whether you're sort of just getting started in the cloud and some of these new concepts are fairly new to you, or whether you're ready to sort of lock the doors and throw away the keys, right? But wherever you are on that spectrum, we want you to leave here today with sort of an appreciation for the art of the possible, right? Again, sort of balancing that you need to choose the approach that's sort of right for you, right for your data. Now, Data protection, like many other sort of terms in the industry, a little bit fuzzy. It means different things to different folks. Just as sort of a demarcation point for us today, we're going to mainly focus on the data security aspects of data protection. We're not going to dive into backups, durability, retention, sovereignty, any of those sorts of topics. If those are interesting to you, and they're all interesting topics, lots of great YouTube videos from this week and years prior for you to digest maybe on the flight home. But we're going to focus on data security. Okay, so before we dive deep into that sort of first theme, let's just do a quick primer on AWS Identity and Access Management, because we're going to see this highlighted quite regularly, right? So the main job of AWS IAM is to authenticate and authorize API calls. And I'll actually mostly highlight the word authorize there, right? Like if that's what I want you to think about IAM doing, is authorizing API calls. Now API calls are some that are obvious, starting an instance, snapshot on a database, but actually we'll see this regularly. Accessing or using a key in KMS is equally one of those API actions that's authorized by IAM. So this is the start of our relationship. Now, IAM is sort of always answering this basic fundamental question: who can access what, under what conditions? We're going to deeply explore the what conditions part of things today, because that's where we're going to really see this unison, this intersection start to happen. Now, the world that with IAM encodes the answers to this question of who can access what into IAM policies. And little warning maybe here, you're going to see some JSON. The policies aren't going to be dramatically complex, but they are going to be there. If that sends you chills through your spine, run to lunch now. I won't be offended, right? But when we think about IAM policies, we're always talking about the PARC model, Principal Action Resource Condition. And that is exactly the manifestation of who can access what under what conditions, right? So we're going to see this over and over. Now, within the world of IAM, there are lots of different policy types these days. It's very helpful to have a little bit of a mental framework for how they all work, how they all fit together. And the simple way that I'll offer for you is to think about policies as falling into two buckets: guardrails and grants. Guardrails are types of policies that specify the maximum that is possible. On the other hand, grants are the policies that actually grant permissions. A guardrail cannot grant permissions. It can only take away. Now, the punchline is that you can have one or more guardrails. We'll see lots of use of guardrails as we go through things here today, but you must have one grant. Like I said, there's lots of different policies. We're going to see organizations' SCPs. We're going to look a lot at VPC endpoint policies. We'll see a number of those guardrails. And then there's always only two types of grants, right? You can either attach permissions to the identity, or you can attach permissions to the resource, a resource-based policy. Now, there's variation. Now, so we've got lots of different policies. They're going to stack, and they're going to work together to achieve the outcomes we're after. When we need to understand the totality of how those policies work together, there are some variations here. So it's important to look at the docs. Take a picture. There's sort of the quick link to the documentation page. But as a broad simplifier, you can think about the effective permissions, whether IAM is going to say yes or no, as being the intersection between what all of those policies say. Okay, so now with that maybe a quick primer in mind, hopefully we've got everybody up to a reasonable starting point. Let's look at this sample application that's going to be our backdrop for today. It's going to keep it fairly simple. We're going to start with a purpose-built AWS account. We've got a purpose-built VPC in there, public-private subnet, nothing too terribly shocking. We're going to build our application today on good old EC2 using the AWS SDK, and we've got the necessary network plumbing to sort of connect out to some AWS services. In this case, we're going to store some sensitive customer data in S3. Maybe think about this as their marketing survey results. And then we're going to use DynamoDB to map customers into various segments. The particular AWS services are not that terribly important, right? The key is just that we've got an app that wants to access some sensitive data. Okay, so let's start going on our journey around data protection. So our first theme, again, is sort of this notion of implementing least privilege against multiple dimensions. And our first assertion, the first thing that we want to be true is just simple least privilege, right? I want my data to only be accessed by the thing that I intend it to be accessed by, right? So we got to start with a grant. We got to actually start by granting access. Obviously, we're going to turn to identity and access management, and we're going to use sort of the Swiss Army knife of the identity and access management world, the IAM role. And we're going to give that role some permissions for that app to be able to access our bucket and our table, right? And when we do that, and when we attach that IAM role to this application, through what's known as an instance profile, the term varies depending on the type of compute you're using, IAM does some really neat stuff on your behalf. It actually provisions short-term credentials. It drops those on the instance underneath the instance metadata service where the SDKs know how to use it, and it actually rotates those credentials on every hour on your behalf, right, without you ever having to do anything. And then the SDK is going to sort of transparently, with no work on your effort or on your behalf, use those credentials to sign those API calls as they go up to the various services, right? We're also going to look at, again, intersecting policies. We're going to use the bucket policy here to start applying some security invariance to the things that we know should be true about accessing these various resources. So let's look at this in practice. This is not a terribly interesting policy, but this is going to get us going, right? This is our basic grant. We've been reasonable about the actions that we want to scope things to. We've been reasonable about the resource that we want, things to, this application to be able to access. But this is just our basic grant, right? That gets us going. This is going to provide us a basic level of permissions to get started. Now, as a quick tangent, the world of least privilege, the world of authoring policies has changed a lot recently. These days, we've got buttons in the console where if you want to let this app run in a lower order environment and mash the button to start with a reasonable starting point on least privilege, that's there. And in fact, we encourage you to do so. So go look into that if you haven't seen it before. And it's getting better every day. So now the companion that we're going to use here to start our journey in this first bit is the resource-based policy. Now this is sort of saying the same thing. This is basically saying the inverse. This is saying deny. I want to forbid access to anything except exactly that role that I expect to use that access my data, right? And this is going to be the start of our theme. We're doing something very purposefully here. We've got the crown jewels. We know exactly the one and only thing that should ever connect, and we use a deny in here to basically say that that should always be true. Okay, so let's start getting more interesting now. So the next thing that we're going to layer in is we built a very specific VPC for this application to live in. And we want to connect to those sensitive resources from that one and only place, and we want to get rid of general purpose connectivity. So there, we're going to turn to our friend, the VPC endpoint, right? We're going to attach those to our VPC. That actually lets us take off that public subnet, and importantly, the internet gateway that's associated with it, right? We're processing very sensitive data. But also, this endpoint gives us a policy enforcement point. So now if you haven't used them before, VPC endpoints, they come in one of two flavors, gateway or interface. And one uses routing, the other uses DNS. But the punchline is as you attach these to your VPC, your application is sort of blissfully unaware. The bits start flowing through this private path without you really having to do anything about it. So now we're going to go ahead and, again, we built this VPC in a very specific way. So let's attach a policy that says we only expect this identity to access this one and only resource across this network, right? This is a great this intersection or this union between identity and encryption also happens to apply between identity and networking, right? And that's sort of what you're seeing here. So again, in some ways it's duplicative, but we're being very exact about what we expect to happen. Now, the other thing that happens when you put that VPC endpoint down there is you get additional context that flows into the decision-making process of IAM. Again, the SDKs do this on your behalf. It's totally transparent to you. But now all of the requests to go up there are decorated. We understood the IAM evaluation engine knows where they originated from. And you can write rules that say, only allow things that originate from the place where I expect. For sort of space concerns, I had to sort of condense down that first that first rule that we wrote a second ago about only or denying anything other than the role we expect. But now we can sort of write a rule of the same flavor, but about network location. Deny, only allow this one principal, and only allow that principal from this one exacting network location. Okay, so now let's get our first exposure to sort of the direct correlation between authorization and encryption. The next thing we want to do is we need to encrypt this data, right? Encrypt everything all the time, all the places. So Kevin's going to handle sort of most of this, but we'll get it going here. So obviously for KMS, we're going to turn, or for encryption, we're going to turn to our great friend KMS. We're going to have, we're going to create a KMS key. That KMS key has itself a policy. A key policy just as a resource-based policy for KMS by a different name, right? And we're going to use that KMS policy. So as the data flows up to S3, we can specify the key we intend to use. We can specify the type of encryption we want to use. And then when the service stores that data, it's storing it encrypted at rest, right? So now there's two sort of things that we've got to do here. First, we've got to get a grant going. We've got to actually give our application the ability to use this key, right? And this is a KMS key policy of a very familiar form. In the top, we specify how can the key be used, right? In this case, we're saying that this key was built for a very specific purpose, and we want the key to be used only by the application we expect. In the bottom, we've got the key administrator, right? We've separated our concerns, we've got a different party, a different principal that is responsible for administering the key, rotating it, whatever they might need to do, right? Now, the bottom line is that the using, and I already sort of said this, but using the encryption key is itself an IAM authorized action, right? One final note before we move on, the KMS key policy is sort of unique in one very specific way. Whereas with most types of resource-based policies in the same account, either could provide that grant that we talked about before. KMS and IAM roles as very security-focused resources, their resource-based policy must say yes. And we'll see that sort of come back later as Kevin is digging into things. But do keep that sort of difference in mind. It is unique in that way. Now, just because we've granted the application access to use the key, we haven't yet specified that it must use it, right? And so here we're going to come back to the resource-based policy once again. You can see this sort of theme that's developing. I'm using denies in this resource-based policy to set what we would call security invariants. These are things that we know to be true, right? And by using deny-based policies, we're absolutely sure that no matter what other policies might start to exist in the system, these can never, explicit deny trumps all, right? Okay, now as a quick, again, sort of tangent, if you were looking real closely, you would have noticed that in the diagram, my actual application wasn't the one that talked to KMS. S3 was an intermediary service that talked to KMS on my behalf. There's a pretty neat technology, at least I think it's neat, under the hood here that's doing this on your behalf, known as forward access sessions. And as you or your application, more relevantly in this case, makes that call into S3 specifying encryption, S3 turns around and gets what's known as this forward access session on your behalf. And it uses that to execute the calls into KMS. And the really neat thing is it's super subtle and maybe not terribly interesting to anybody that is really deeply worried about security and identity stuff, is that allows two things to be simultaneously true. One is it respected your permissions. It wasn't S3 doing it. It did it with your permissions. But it also allowed KMS to differentiate between you and between S3 working on your behalf. Again, if that's a thing you want to sort of geek out on, take a look at the link there. It's really, really exciting technology. Okay, so let's keep moving on. Let's keep tightening down the ratchet even further, right? The next thing we want to do, we've been pretty exact thus far about like the very specific combinations that I want to use, but maybe we want to just to have belts and suspenders, just to have a little bit extra assurance about what's going on. Maybe I want to put some higher order guardrails to make sure that even if again, maybe I screw something up in one of those policies, I'm sort of protected, right? Defense in depth is always a good thing. So there, we're gonna first look to a service like AWS Organizations and the service control policies that go with it. Now, what's interesting about service control policies, and if you're not familiar with organizations, is that this hierarchy, right? We've got management accounts and we've got member accounts, right? The management accounts where these service control policies exist can exert that guardrail over top of the account. And say that, again, even if there was a policy that existed in the account that said star, 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 just wide open, the worst abuse of least privilege you could imagine, that service control policy using that maximum allowable permissions thing that we talked about before narrows us back in. So we're going to start, again, we're going to use service control policies to create more of those security invariants. A simple example here falls into the general theme of what we would call a data perimeter. This policy basically just says that no matter what else is true, I just want to be sure that the only objects that my organization is accessing also belong to me. I don't want any, other external organizations' data sort of, perhaps creeping in, right? Now, there's a lot of work that's gone on for many years to sort of curate the best of these data perimeter policies. They sort of generally work across the three axes that you're already seeing here, identities, resources, and networks. But there's a great library of policies that are up there that our identity solutions team has been curating to help you get going. That, it requires some exceptions for when things are working on your behalf, so go just check those out and consume those directly. Another type of security control that we might use an SCP for is a solution of this write once dynamic application type of control. In this case, we want to weld, this is my cheeky way of saying it, we want to weld the security credentials to the instance they were issued to. So I can write a policy that understands, we talked before about how IAM delivers those credentials to the instance. Well, now we're decorating that credential with that information. And you can write a policy that uses policy variables that just says, I want this to always be true. I always want the credential only to be used from the instance and the VPC where it was issued, right? And what that saves us is having to write the similar type of rule downstream in lots of policies. We do it here once, we set it once, and it applies everywhere. Okay, now again, same as before. Once we've got an organization, that extra context further feeds into our evaluation engine, and we can come back to our resource-based policy and write that too. Definitely belts and suspenders mode, right? What we're doing here is, again, we've got all of our fine-grained stuff up top, but we're using the broad guardrail as just an extra double check. And the reason that is useful is the policy statements up top are very, very specific. They're very unique to the principal, they're very unique to the key, they're very unique to the bucket. There's probably some other stuff that you've thrown in there. This bottom policy is very standardized. You can look and test for this, with a very structured, automated approach. It's gonna look the same in every bucket policy you've got, right? And sometimes that is just a great way to double check again, make sure somebody hasn't fat-fingered or otherwise screwed up a policy. By checking for this in all your bucket policies, you sort of achieve that nice guardrail at scale. Okay, now the last thing I'm going to walk through before I hand it over here to Kevin is at this point in our journey, we've gotten a long ways to defining a very exacting environment, right? We're being very exact about what we expect the access from our application to be. And now the evolution that we want to take is we want to use that exactness to actually, we've prevented anything bad from happening, but now we want to use even the attempt outside of those bounds to be a very high signal indication of something going on, right? Now, that something going on might be just a simple code bug, right? It might be a security event, but either way, we're going to look into it and figure out what's going on. We're going to use maybe another account in our structure here. Most folks will refer to this as a delegated administration account, where we might have tools like GuardDuty or CloudTrail. That, again, this is sort of the central hub for our organization where all this data is flown into. If we really want to get fancy, we could actually start doing some of these operations using Event Bridge literally every time a transaction fires. So whether we do it periodically or whether we do it event-driven, sort of choice is yours, but there's some really neat things we can do. First tool you're going to almost invariably turn to in this space is Amazon GuardDuty, right? Amazon GuardDuty has done all of the sort of rich ML work for you, and what it spits out are very curated and actionable findings. There's lots of different finding types that GuardDuty focuses on, but the ones that are really relevant to what we've been talking about today is there's a lot of stuff around anomalous behavior of IAM roles, right? So we prevented, with the credential control, anything from walking away, but this will give you an alert if something was even attempted, right? Similarly, for like any sort of behavior anomaly around rates of access or anything that's out of the baseline that it detects, it's going to fire you a good actionable alert, right? Just make sure somebody is listening to the other end of the queue. And then lastly, again, maybe this takes a little bit of time, especially in a retrofit environment, to get to this point of maturity, but we've been super exact. We should never expect an access denied message to appear in CloudTrail. So you can use any sort of tool that you want for this. There's great partner solutions. There's stuff from AWS. Security Lake might be, CloudTrail Lake might be a great example of where we would go with this. But we can write, it's probably a little hard to see on the screen, we can write a simple query statement that looks for the number of denies on this given bucket over this given time, and we should always expect that number to be 0. Literally 0. And an indication of anything other than 0 flows into our incident response process, right? And so lots of great things we can do here. But again, what we've done now at this point has been very exact about the conditions we expect. And we've also taken that even further and used that as a great high signal to noise ratio of anything that might be going on. So at this point, I'm going to hand it over to Kevin, and he's going to keep us going.
All right, thanks, Quinn. So without further ado, I'll pick up where Quinn has left off, but starting with a quick primer on the KMS service itself. So I would imagine everyone in this room have heard about KMS, and you're likely using it somewhere today. But for those who have not, I'll quickly talk about the most salient point about our service. As the name of our service states, we do key management, but at scale. We protect millions of customer-managed key while processing hundreds and billions of requests every single day while adhering to the core tenets of security and availability. You can use our service in isolation, but you probably have used through one of the service integration that we offer, such as S3 encrypted bucket or EBS encrypted snapshots and volume. These are commonly referred to as the server-side encryption. But what do I actually mean by key management at scale? How do AWS services obtain a key from us and encrypt the data respectively? To do this, we use a process called envelope encryption scheme, where we provide a data key to each AWS services, and they encrypt the data with it. And this data key is then encrypted by your KMS key. So your KMS key acts as a root key that locks all the key underneath. In order to decrypt your data, you need access to your KMS key, which is then to decrypt the encrypted data key. And this data key is then used to decrypt your actual data. To safeguard your key, we use a FIPS-validated hardware security module. Your key never leaves the premise of our service, and it only exists in a plain text version for the fraction of a second that we use the key for. FIPS is considered the golden standard within the cryptography for secureness and correctness of the cryptographing module. And recently, we were able to reach security level 3, which is considered the bar for running critical healthcare, government, and financial workload. So one of the questions we get from customers a lot is, how should you be managing your keys? Where should you be storing it? And how do I prove to my auditor that I'm doing the right thing while meeting my compliance obligation? So our second theme is enabling compliance without sacrificing developer velocity. So next assertion we have is you want to balance the need for your distributed teams to build applications while your central security team ability to provide assurance regarding your data protection posture. So on the diagram you see on the left, the keys are created within the account where they're used at, so it's a distributed manner. And this is all about giving your individual team the autonomy and reducing the blocker the team faces. So your team manages the key policy and the lifecycle of the key itself. The governance is largely done through the outside mechanism, through the detective and preventive control. And the example you see on the left, the logs are centralized into a single account that you can dedicate for any kind of auditing purposes for your central security team. On the diagram to the right, you have keys that are confined into a single account, so there's more strict and physical control over the keys themselves. These keys are often controlled by your own central security team, and they're vended out to each individual account owner by changing the key policy. One of the benefits about this model is that since the keys are already centralized, the logs are centralized as well, so you don't have to take any extra step to centralize your logs. So second question we get is, where should I be storing my key in terms of compliance perspective? So our recommendation all the time is that you should use native KMS, which offers you the best in performance and security, durability, and availability. Now, as you move towards the right side of the scale, what you're doing is you're trading up the performance aspect of it for better control and ownership of your keys. So the second option we have is something called import key. And in this option, you're generating your key outside and you're uploading it to KMS and using it within our environment. This is commonly referred to as the bring your own key method. And since your keys are within the KMS environment, you get to enjoy the same availability and security aspect, but the durability belongs to you. At any time, you have power to take out the key and to meet your compliance obligation. The third option is called custom key store, and this is for customer who prefers having the isolation and independence of having your own HSM in the cloud. You create your HSM instance within the Cloud HSM service, and then you link that HSM through the KMS, and all the data plane operation for the key will happen within your own HSM instance. From the security, durability, and availability perspective, you own that, but you're assisted by the Cloud HSM service. The last option is called external key store. And in this option, your keys are created from outside and used from outside as well via network call. Your HSM that stores your key can be located anywhere. It can be on-premise, it can be another cloud provider, or it can be even your laptop if you desire. The communication between your HSM and the KMS is done through the proxy that we developed, which facilitate the network calls. In general, we do not recommend this model unless you have a very strict regulatory workload that requires you to hold on to your key. You own the security, durability, availability of the key itself. So if your HSM goes down, then your AWS workload that depends on that HSM will go down as well. So you should be very specific as to where you're using external key store, and only for the workload that requires that compliance requirement as well. So summarizing the last two slides, our general guidance on key management is actually relatively simple. You should create the keys in each AWS account where those keys are to be used at. Putting it another way, you're tying the key to the data owner themselves. We believe the data owner is best situated to decide how they will use the key, so they know the performance characteristic they're looking for to pick the right key store. And data owner also knows who needs access to that data, so they can change the key policy accordingly. And lastly, it offers the most flexibility down the road because there's less thing to delegate, and you don't have to deal with any kind of cross-account permission issues eventually. In the end, though, there's really no right or wrong answer here. It's all about making the right trade-off between what your operation is capable of versus what you want in control. Distributed, centralized, or even hybrid model, they can all work. The question should be, what is the management burden on you? Sometimes your compliance will compel you to pick one model for another, but you should really challenge your team and ask them to be really concrete about what it means to be in control of your keys, as that will help you dictate which key store that you need to use. Lastly, having the right process and auditing mechanism is important. There are many AWS services within, such as AWS Config, Security Hub, and IAM Access Analyzer, that you can take advantage of to build the right management model that works for your organization. So your team needs to shift away from simply managing the key itself to building the right tools and process to encourage the right behavior in key management. So coming back to our architecture that we left up, nothing really much have changed, but we talk about different key store, key management style, and server-side encryption. And to be frank, most of you will probably stop here. This is good enough. But what if you're dealing with highly sensitive data that you cannot afford to get leaked or compromised in any way? So anyone with the right credential in this architecture can assume that role and take over the system. So what if you have an outside threat actor that steals your admin credential? What about the insider threat? Maybe internal threat actor, such as your own operator and admin taking over the system. What can we do about these kind of scenarios? So this brings us to our next theme, which is protecting data from your own system administrator and operators. And our next assertion is you want to verify that your data is protected against scenarios where no single individual can modify the policies that enforce these conditions. So within KMS, you can use a concept of separation of duty and apply them within the KMS key policy. And separation of duty, all it means is that you're delineating between who can use a key versus who can manage the key itself. And you want to do this because it helps ensures that no single individual within your organization has all the permission required to perform malicious action. So KMS key is a little bit unique in the sense that it requires explicit allow statement in order to use the key. So using this property, you can create a second logical layer of control for your data. So let me demonstrate that with an example. So on the diagram to the right, you see a bunch of users who has access to this S3 bucket. They own it, so they have power to change the bucket policy, and they're managed by the IAM policy itself. So that is your first layer of control to your data. But as soon as you're adding the KMS key on top of it, what you're doing is you're creating a second logical layer of control. These users now require access through the KMS key as well in order to access your data. And you can separate the who managed the key by having key owner manage the key policy directly, while the key users cannot make the changes. I do want to caution you that we are only solving this problem from the KMS perspective, though, because eventually you need something that ties this principle to the actual human identity behind it. And one way you can solve that is to use AWS IAM Identity Center. So once your user performs single sign-on, you can map their credential to the right role and group that belongs to your organization. So now that we addressed the permission issue on the policy, what about the data itself? So our next assertion is you want to verify that your data is encrypted end-to-end so that no data can be exposed to any third party. And one way we can address this is to use client-side encryption. And essentially what this means is that you're encrypting your data as soon as it's produced and decrypting at the end when it needs to be processed. But client-side encryption does introduce some complexity to your design that you need to be mindful of. First one is key management. So it's actually very easy to encrypt some piece of data with some random key. But what should you do with the key afterward? How do you distribute that key, and how do you safeguard that key? And luckily, you have KMS to help you with that. So you can create KMS key, encrypt data with it, and you can share them with other party by simply changing the key policy. Second, when you're encrypting your data, what you're doing is actually trading portability of your data for better control and security of your data. So for symmetric encryption, there's no agreed upon standard as to how the ciphertext should be formatted like. So any AWS services or other services, encryption library, SDK, they're free to implement whatever ciphertext format that they desire. So the producer and the consumer also needs to agree upon what that ciphertext should be formatted like before they can exchange data. Despite this complexity, there are benefits to use client-side encryption, and we already talked about one already, that is limiting the data accessibility. As you're encrypting your data end-to-end, you're preventing intermediate party from looking at your data, and that helps you reduce the surface area for attack and also limit the compliance scope as well. If you're also working within the multi-tenant environment, like SaaS application, chances are you have multiple customer data intermingled within a single data store. So to provide better isolation between your customer data, you may want to use encryption. As your customers are growing conscious about how their data is kept and used on your platform, you may have run into a scenario where your own customers are now asking you to encrypt their data using the key that they provide. And in this kind of scenario, you have to use client-side encryption, and you can take advantage of KMS for key distribution issue. Lastly, as a way to mitigate risk, if you're working with the data that is deemed highly critical for the business to handle, then you may want to use client-side encryption to protect the data and adding another safety net that you can rely on. So how do you actually perform client-side encryption within AWS? Luckily, you have two great encryption SDK you can take advantage of. The first one is called Encryption SDK, and it's designed with ease of use in mind, very easy to use, hard to misuse, and it picks the right algorithm for you so that you don't have to make the complex decision. It performs the envelope encryption automatically, so you don't have to do it by yourself, and has integration with KMS for key management as well. The encryption SDK is available in open source and in multiple languages. So you can encrypt something in a Java environment, let's say, and decrypt it at the other end using Python or JavaScript if you desire. Database encryption SDK shares the same concept as the previous one, but focus exclusively around structured data, specifically DynamoDB. The SDK is aware of your table structure, how the columns are laid out, and which field needs to be encrypted, signed, and verified. One of the unique features of the SDK is that it has ability to search on encrypted data. So once you create a query using the SDK, it's able to search through the encrypted data without revealing the plain text underneath and return the result back to you. So coming back to our architecture, I'll now add client-side encryption to this. But before I do so, I would like to just simplify it a bit by zooming into the main application only. There we go. And now I'll be splitting this application into two parts, the producer and the consumer part. The producer will focus on getting the data and encrypting it immediately, whereas the consumer will pick that encrypted data and process them. So now I'll add the encryption algorithm to this mix. So as soon as the data is received, it gets encrypted, and the encrypted data and the encrypted data key is placed into the S3 bucket. And then the consumer application will pick that up, process it, and give the result back to you. To achieve this, we're using two KMS key here. So the first KMS key, we already had it before for server-side encryption for the bucket itself. And the second KMS key is used for client-side encryption, where we are using to encrypt your actual data itself. So now we have effectively prevented intermediate party from looking at your data. But smart observer may have noticed that all we did here was reduce the scope of the authorization from the system level to the key level only. And in theory, your own admins and operator can collude each other and gain access to the key and gain access to the data. So how can we prevent that from happening? And this brings us to our next assertion, where you want to verify that your data is protected from your own operator and admin, even while the data is being actively in use or being processed. But before I talk about this, I do want to introduce a new topic called confidential computing within AWS. Confidential computing is defined as use of specialized hardware and associated firmware to protect your data while it's being processed. And I put the emphasis on the while the data is being processed. We covered data at rest pretty extensively. That is a server-side encryption and client-side encryption. And data in transit is covered by the TLS connection that it forms when you connect to our service. There are two distinct security and privacy dimensions that a lot of customers care about when we talk about confidential computing. The first dimension is protection of your data and the code from cloud operator, such as ourselves. And you get that protection by default today through the Nitro System. The Nitro System provides enhanced security and provides you with isolation between the tenants as well as from our own operators. The second dimension is protection of your sensitive data and the code from your own operator and admin, and this is what we're interested in. This is solving the data in use case. And this is what Nitro Enclaves aims to solve. Nitro Enclaves are highly isolated, constrained, and virtualized machine, giving you additional isolation for data within your application while it's in use. The enclaves are created by carving out a piece of CPU and memory from the parent instance and running it in parallel with the parent instance itself. The communication between the parent instance and the enclave is done through the secure local channel called VSOC. There is no networking on the enclave itself, no persistent storage, no root access whatsoever. So you can kind of think of the enclave as a black box. Once it's running, you provide a piece of data to process it, and it will give the return result back to you. So coming back to our architecture, we'll now simply drop in the enclave into the mix. And here, I simply shifted all the decryption process into the enclave itself. Now, I could have done the same thing on the producer side, but I just choose not to do so for simplicity's sake here. But you can do so if you want. Now, some of you might be thinking, I just told you that enclaves are highly locked down. There is no networking, only through the local channel only. So how do you get access to the KMS key itself? How do you even trust the enclave to do the right thing and it's running the right code? And this brings us to our last assertion, where you want to verify that your data is only accessed by the exact software that you intend. So KMS is a little bit unique is that it can attest the identity of the running enclave using cryptography. So now we're narrowing the authorization from simply the role itself to the actual machine itself. When enclaves boots up, it takes a series of measurements about itself, such as a bootloader, the kernel, the code itself, and some metadata about the parent instance. These measurements are then calculated as a hash values and recorded onto the attestation document. And the attestation document is passed to the Nitro hypervisor, who validate that it indeed came from the Nitro enclave, and it signs it with its own private key. This is then sent to KMS to be validated. So we check the signature on the attestation document, make sure it's correct. Then we evaluate the attestation document against the key policy itself. So this is what the KMS key policy can look like with the enclave attestation shown. So the important part here is the bottom here, the condition part. where we're defining where this key can be used. So we're telling the KMS that this key can only be accessed when the measurement of the enclave exactly matches. So we went from simply, does this role have a right credential, and is this the right user who's trying to access the key, all the way down to, is this software running in this exact configuration in place and signed by this entity correct? And once all of these matches up, we grant access to the key itself. Now, I skimmed through a lot of details and to get to this point, so I would like to take a step back and kind of explain to you what happens in real time when you try to access the key from the Nitro enclave. So first, we need to fetch some data, and this is facilitated by the Enclave SDK on the parent instance itself. So Enclave SDK will use the instance profile of the parent instance to get the right resource from the outside and bring it back to the enclave environment. So once we have encrypted data and encrypted data key within the Nitro enclave, we send the encrypted data key along with the attestation document to KMS. And KMS will validate that, the attestation document, see if the document and the key policy matches up, and grant access to the key once all of these conditions has been met. Now, this is where it gets really interesting, where we use a little bit of asymmetric cryptography for the next step. So within the attestation document, there's actually a public key of enclave embedded within it. So what happens is that once we decrypt the encrypted data key using your KMS key, we re-encrypt that plaintext data key using the Nitro enclave's public key. And then we send that straight back to the enclave to be decrypted. So once the enclave has it, it will use the private key to decrypt the re-encrypted data key. And now you have the ciphertext along with the plaintext data to decrypt your data and get your plaintext data back. So we're at the end now, just adding the last piece of puzzle, which is the enclave attestation document. And this completes our journey, hardening your application so that only the machine itself have access to your data. And to get to this point, what we did was we intertwined authorization along with encryption together and using KMS as a gatekeeper to your data itself. And with that, I'll pass along back to Quinn.
Awesome. Thanks, Kevin. Cool, so let's finish it up here, right? You know, in somewhere about 50 minutes, we went through starting with some pretty basic least privilege and worked all the way up to an architecture where the data can literally only be decrypted and operated on from within a space that's essentially welded shut, right? Nobody can get there, not us, not you, not anybody, right? I think that's pretty incredible. We also saw a journey where at first, really authorization was our method of getting into the encryption world, but we then at the end came sort of full circle. We're actually using the cryptography to enhance the identity, to make even a better assertion about the who in the who can access what within the park model, right? So pretty amazing in my mind in terms of data protection. So now, that said, it's always important to keep the balance in mind, right? So we walked through, you know, starting with some reasonable scope permissions, then we looked at isolation, we looked at sort of more granular least privilege, and we ended up all the way at, you know, where, again, we've got these hermetically sealed systems where there are no doors, so therefore there aren't even any locks, and even into cryptographic identity. Where you fall in the spectrum is gonna be a function of your maturity, right? Where you are along sort of the adoption curve of AWS, where you are in terms of a whole bunch of maturity in terms of software engineering and other things, right? So you might find yourself at many different points on this curve. It's also pretty reasonable to think about that, you know, you are not just singular, and you're not gonna have just one pattern for your organization, right? You need to be dialing these patterns in accordance to the data that you're protecting, right? We do not need to take, you know, a little sandbox experimentation and put it in a Nitro enclave. We probably also need to do something better than fairly rudimentary least privilege for our crown jewels, right? And so there's not, this is sort of broad advice across the cloud, but there's not going to be one size fits all here. You're going to hopefully mature over time across your different workloads. And the hope is that you sort of take what we've incubated with you here today and use that to templatize repeatable patterns that are consumable across your organization and have them be incrementally applied. As time progresses, maturity hopefully increases, and you're going to be storing more and more sensitive data up onto AWS. So, yeah, in summary, right, so do think about this unison, this very unique unison between authorization and encryption in AWS as a way to improve your data protection strategy, but also do think about this as being incremental, better everyday security, right? And with that, let's close it out. I thank you all a ton for spending an hour of your lives with us. Kevin and I are going to wait out in the hall, and we'll answer any questions that anybody's got for as long as you guys have got time and interest. And please do fill out your surveys. They're super important to us. I'm sure you've heard that a lot. So please, we would really like your feedback, and hope you have a great time at the party tonight. Thanks all. Appreciate it. Cheers.